Welcome to Würth Knowing. Today, with a special guest that you might have spotted on our set before. He is here in person, Chris Tribble. Chris, you are here today to talk about, you say it?
Structural bolting.
Exactly, that's it. Chris, what is structural bolting?
So structural bolting, really what we're referring to is complex steel structures. So any place that's a steel building that's more than 2 stories tall, a bridge, highways, something like that. Complex steel structures where we're only doing steel to steel connections. We're not trying to bind to any other materials.
So anything that really needs to be robust and kind of hold the test of time.
Exactly, yes.
So why do we call this a structural fastener? Is it even important? What is the difference to like a regular fastener?
So with structural fasteners, it's really specific about the designation from the ASTM.
What is that?
ASTM is the American Society for Testing of Materials. They write the consensus standard, and with this particular standard, it's a product standard. It's ASTM F3125. It's a product standard that gives you everything from chemistry of the material all the way down to final shape and size, and it's really going to break the products down into grade or group, type, and style.
And I guess that's really important for the safety of all of these different usages that you brought up, because you want your structural fastener to actually work for the purpose it's been designed for.
100%. As long as you're following the standards, it's going to perform the way that you've designed it to, and it's going to hold up for ultimately what you need it to do.
So let's talk a little bit about what you just mentioned, grade, type, and style. I always try to remember it by GTS because it helps me out. I would really like to hear your take on what is the difference between grade, type, and style, because I feel like I've heard it a bunch of times before, but it kind of gets mixed up a little bit in my head.
So let's start with grade and group. So ultimately, what started as 4 different standards were rolled into one consensus standard that really addressed the material. So the A325, F2280, A490, and F1852 all came under this one standard. And initially with that standard, that grade mark remained from the old standard. What we've done now is those grades are determinant on their ultimate tensile strength, their breaking point. And that falls into the groups of 120, 144, and 150 KSI. So now when we're talking about grade and group, we're talking about that performance metric.
Is the higher the better, or what does the grade actually show us?
So it's really the ultimate tensile strength of the material. So if you were to imagine, if you had a steel plate and it's got a certain number of holes in it, with a lower grade bolt, you're gonna need more bolts for that same connection.
Okay.
The higher the grade, it's less bolt holes, which means less bolts, but you're still getting that same kind of performance. Ultimately, that's gonna come down to the design of the engineer and what their connection type is and what they're trying to accomplish.
But so for non-engineers, let me put it that way. For non-engineers, when you're thinking about the grade, if you would have to like summarize it in one sentence, what does the grade tell us?
In simplest terms, higher is better.
Okay.
Higher is gonna be stronger.
Mm-hmm. So kind of the strength of it all.
Exactly.
Let's talk about style.
Okay.
Or type. Which one do you prefer?
So I'd say let's go to type, because regardless of your grade, both are gonna be available in either type. And the types are type 1 and type 3. And what that's
What happened to type 2? Sorry, I need to interrupt you there.
No, it's a good question. Type 2 is really about high temperature, high pressure service. With our application, that doesn't really apply, because it's seldom that you're gonna have a complex steel structure that is also undergoing that high temperature type of service that you would think of like a boiler room or something like that. So type 2 ultimately was removed in the 90s. And the only real difference between type 1 and type 3 is type 3 has a copper content minimum. So there has to be so much copper in there. It's what you may have heard referred to as weathering steel.
Oh yeah, I've heard that before.
So it can either be aesthetic or it can be functional depending on the situation. But that's the only real difference in type. And again, it's important to remember that all grades and all styles will be available in both options. I know, I nodded too hard and flipped my hair down.
So we have type 1, type 3. We lost type 2 in the 90s, like so many other good things. And then the only other difference is that there's a minimum copper amount that needs to be in type 3.
Yes.
Now, what is style then?
So style, and it's a little bit easier to kind of express that to you visually. So when we're talking style, hex head pattern,
Oh, okay.
or what's known as a twist off. And this is really just about the installation method. So this twist off could either be a button head or it could be a hex, it doesn't matter. But most importantly is this spline here. And when we're referencing style,
This here?
yes.
Okay.
When we're referencing style, we're talking about, is it a hex bolt or is it a twist off bolt?
Okay. So just 2 types.
Exactly.
No secret third type.
No secret, nothing special, just those 2 styles.
Nothing disappeared in the 90s in that case.
Not for this one, no. There's an aesthetic difference between these. There's a labor difference with installation. There's all kinds of differences, and it's really going to be up to the engineer of record to decide what the right fastener is for their project.
Well, speaking of engineers, I actually do have a question for you because it seems like I get corrected all the time by them when I talk about heat and lot. Is there a difference? Because for me, it seems like it's very similar terms on what they mean.
So there is a difference, but correcting is what engineers do. That's their whole game.
Don't we all do that?
So the difference really ultimately between a heat and lot is heat is when you're starting with your base steel. It's whatever that melt of steel comes out of. Each heat can produce multiple different lots, but ultimately the lot will all have come from one heat.
So would you agree if I would say a lot is like a batch of something, but like one specific one that I can number, I can trace, but it can only be from one heat?
Absolutely.
Okay. But one heat can produce multiple lots.
Yes.
Okay. So kind of like if I think of my previous experience in the grocery industry, that's how we used to package products. They were in lots so that you could trace if something was wrong with it or not.
Yeah, ultimately, so you can get down to the smallest minute level if there was ever a problem. Of course, there would never be a problem with our bolts.
That's why we have standards, right?
Exactly.
Of course.
But if there was, you can segregate the smallest possible by the lot rather than throwing out an entire heat.
All right, so you're telling me we got grate, we got type, we got style, we got heat, we got lot. Now, obviously, my next question on this would be, how do we make sure with all of these specifications that the right product gets to the right place at the right time? Because I feel like there's a lot of, conflict or potential for error.
Yeah, so there's a lot of different information. And where structural bolting job sites tend to differ a little bit is we're talking about complex steel structures. Bridges, highways, brand new skyscrapers, whatever it may be. So our job sites aren't going to be a warehouse or someone's garage. They're going to be coordinates on a map or the side of a highway or a brand new building that doesn't have an address yet.
Like that random thing you stumble up on Google Maps where you're like, what are they doing here?
Exactly.
Okay.
Where you see all the cranes moving around and they're just moving dirt. That's what we're talking about. So it's important with structural bolting when the material gets there, number one, that it's labeled. We've got all the documentation to back it up, but we need to make sure that the container it's in is also protecting the material until it's time for installation.
But wait. Actually, this is now confusing me a little bit. Structural fasteners, we use them in our most exposed to the environment type of products. Why is packaging important if they're going to be exposed anyway?
So yes, ultimately they will be exposed to the environment, but the design that's going in within the threads, we have to protect that relationship to make sure that they're going to perform the way that we want to. So if you think about, hey, you have a car, your car has tires. If you leave the tires on the side of your garage and they start to get dry rotted and gross and then put them on your car, it's not the car's fault that the tires are no good anymore. Similar with this, we have to protect that torque tension relationship within the fastener so that it'll perform the way that it needs to. Once it's installed, it's going to stay there, and that's when we can really get to the exposure.
So it's like protect till engage,
Exactly.
basically. Oh, that makes more sense because I was always confused of why everybody makes such a big deal about proper packaging and stuff if it's getting exposed to the elements anyway. But I'm guessing the proper packaging is not just like, a card box or anything.
You're 100% correct, because steel kegs, or whether it's a high density plastic keg, something like that, something that's going to protect the material until the time of installation. And whether you're using a steel keg or you're using a plastic bucket, the big thing is going to be the lid. You can see in the lid here we've got this gasket. That's what's ultimately going to keep the material protected. so that it doesn't have the environmental exposure that it would have if you left it in cardboard and the cardboard broke down or any of those kind of things.
And without that, basically it would not be protected from the elements, right? Because when you gave me this, I thought of like, oh, I have something like this at home, basically.
Yeah. And honestly, you probably did. Ultimately, that gasket is what's going to be most important to really keep it protected as best we can from the environment. So kind of got some examples here to show you. This was kind of a smattering of stuff I grabbed out of our warehouse, and I thought, let's see what happens when we don't do it the right way.
Oh, so like your little island of misfits, where did they all come from?
So this kind of first group here, I thought I'm not just gonna leave them in a cardboard box, I'm gonna put them into a bucket. And so I put that bucket out there, didn't have a lid though, so ultimately it got that exposure to the environment. This next group, I thought I'm gonna do a really good job. And I'm not just gonna put it in a bucket, I'm also gonna put it in a bag. And I sealed it in the bag and it got that exposure. The last being just like you're supposed to. Bucket with a sealed lid, and we put it down as well. This is about 10 days later, just from being in the back of our warehouse, not in a particularly arid environment, no sandstorms, anything like that could really affect this. This is just oxidation and exposure.
That one looks much cleaner than the other two. But that brings me to one question, because in your little island of misfits, I also see some rusty examples. Now, I've always been told that some structural fasteners are designed to rust. Is that true?
Yes, so when we talk about the type 3 fasteners, that copper content is what's gonna lead to oxidation, and that rust is actually your protective barrier for the steel. However, you can't have that rust before you get them actually installed, because it's gonna affect your torque tension relationship within the threads.
So we're protecting before engaging. Again, okay, that makes sense. So basically, this is what it would look like after, but you don't want it to look like until you've used it.
Yeah, you're right. So with this one specifically, you can see how this oxidation has started in the threads. That's gonna affect your torque tension relationship. Afterwards, when you have your type 3 steel that it's connecting, the whole thing's gonna oxidize together. It's gonna be beautiful and aesthetically pleasing. But right now, all it's gonna do is mess up your installation.
So buckets like these, this type of storage is what actually helps us to get the right product to the right place at the right time in the right condition.
Definitely. It's gonna protect your material until it's time to actually let it perform, and it will make sure that that performance is exactly what you need.
As solid as a bridge sounds really offensive. And I don't want to say that because I feel like the week we're posting it, some bridge somewhere will collapse, so.
Yeah. So Michael, I'll say if there's any good news, the RCSC, the Research Council on Structural Connections, they write a specification devoted entirely to structural bolting and references back to the ASTM specification. They have a whole section, section 2.1, that explains protected covered storage. And what they mean by that protected covered storage is that you're gonna have it in a place where it's easily identifiable, it's gonna be sealed up and protected, and then ultimately that you're only taking out what you need for each shift. And then when you go back at the end of the day, if you have some left, you put it back into the protected covered storage, and that way you know it's gonna perform exactly how it should every single time when you go to install.
So the storage in that case is also not just a one-way storage. You would reuse that basically.
Absolutely, as long as it didn't get incorporated into the work that day, but you want to make sure that it's back into the protected covered storage. Again, on a job site, it could be a Connex box, it could be a lean-to, it could be a warehouse with racks. It really depends on your project. But ultimately, you want it somewhere where it's protected as much as possible from those elements.
So proper storage is really important. Otherwise, all that happens to the product is that they end up on your little island of misfit over there, right?
You're right, and that's definitely not a place you want to end up. The reason it's so critical is because these parts are so critical. And the storage leading up to that is gonna lead to optimal performance of the material as well.
Well, and you better believe that the next time that I'm gonna pass by any construction site that looks like it's still an unmarked location, I'm gonna check their storage. That's what you really taught me today.
Exactly. The good news is the standards exist, and the organizations that deal with this kind of material, they do a great job. So everybody's protecting their material to make sure that it's gonna perform exactly like it's supposed to when the time comes.
An additional piece of good news is that we have people like you, Chris, who can explain this to all of us. And I hope you all learned as much as I did on this episode of Würth Knowing. See you the next time.
So we used to have this thing we would say, which was, if a regular fastener breaks, your chair falls apart. If a structure fastener fails, people die. But that may be a little too...
No death.
Okay.
No death.
That's not what I thought you were going to say. I thought you were going to somehow bring a chair. I was trying to think quick. I was like, how's the chair going to get into a bigger failure?
I think I'm gonna do. I have an idea. I can do something like. So what this really taught me is that the next time I drive anywhere, I will make sure, or I will keep in the back of my mind. I hope they stored all of this correctly. I hope they stored all of this correctly.